So I'm going to speak to you briefly about mathematics and physics at the University of Bristol. I'm myself in the School of Mathematics. I'm the international director for the School of Mathematics, and I do statistics and probability, right? And the 15 minutes isn't going to be much, but I hope it gives you some idea of why you want to study mathematics or physics or statistics or data science, because that's the sort of thing we offer. So first of all, let me just spend 1 minute on why you want to study mathematics, statistics, physics, or for that matter, chemistry. It is because we're talking about science here, and mathematics is the language of science and engineering, and increasingly it's also the language of economics and finance. And you may know that many of our graduates go on to jobs in banks and in the financial industry. And the reason they go on there is because they know mathematics. They know about how to deal with the world in a mathematical kind of way and in a scientific kind of way. And this holds true for physics or chemistry, right? And our graduates have a wide range of career options. So usually the typical graduates go on to banking, consultancy, or IT. A profession in that sort of thing if they don't go on to postgraduate studies, but many of our graduates also go on to postgraduate studies, not necessarily in math, but also in engineering, in computer science, some in finance, also in data science. And the truth is, if you want to do serious math as a career option, you need to do postgraduate studies. But nevertheless, you can just get a bachelor's degree or master's degree, and you can go on to an industry that's not directly related to mathematics, but it uses this kind of skill that you learned studying mathematics or physics. And it is because the experience of studying these hard disciplines, so mathematics, physics, they are difficult and they're challenging, but they are also rewarding, okay? Because it is creative. They are creative. And don't let people tell you that mathematics is not creative. It is absolutely creative, but to be creative in mathematics takes a lot of effort. That's the reason, okay? And you develop strong critical thinking skills, and people know that. Companies know that. So therefore, they want to employ mathematicians or physicists or chemists, and so all these hard science degrees are highly respected. So that's why you want to study a hard thing, even though you may not want to do this, as a career option. But if you want to do that as a career option, that will be even better, right? So why would you want to study math at Bristol? So I'll go on to physics. I'll talk about physics in a few minutes' time, but let me focus on math for the minute. So why do you want to study math in Bristol? The reason, well, first of all, we have a highly ranked department. We are ranked 5th in the UK Research Excellence ranking. And our degree structure is designed to be flexible, right? So some degrees, so at some universities, degree structures are designed to be sort of rather rigid. So you do what you're told. But here in Bristol, we design degree to be flexible. So you choose what to do, and we have a variety of deep and engaging options in the second and third year and the fourth year for you to choose for your own specialty, right? And we also have a nice building. So this building is, it may not look that new. It's actually more than 100 years old, but this is a world-class facility. That's it's a nice building that looks nice on the outside, but has been fully refurbished from the inside as well. It looks really great from the inside with high ceilings, and you can tell the windows are really tall. So that's why you want to study mathematics at Bristol. It's a nice place to live, and we have a good degree structure, and also we're highly ranked. And the kind of structure, so what degree courses do we offer? So what we have is like chemistry and also physics, we have either 3-year option or 4-year options, all right? So with a 3-year, you get a BSc degree, so Bachelor of Science degree. And with 4 years, so you spend 1 extra, you get a Master of Science degree. And we have these options. So these are, so the first 3 are entirely taught in the School of Mathematics. So math with stats for finance. So the last one has a bit more focus on finance. So these are so-called single honors degrees. So this just means that this is almost entirely taught within the School of Mathematics. We also have joint degrees. with computer science, economics, physics, or philosophy. So these are sort of split between the School of Mathematics and another school. So in this case, School of Computer Science, for example. And you spend roughly half of your effort studying mathematics and half the effort studying computer science. So if you are interested, let's say, in both math and computer science, you may want to choose a so-called joint degree, right? So as with many other schools like chemistry, you also have the option to spend your third year in an overseas location, overseas with regard to the UK, right? Okay, so another new thing that I want to tell you about is just this year we have a new data science degree. So we also have a 3-year and a 4-year option. Okay, so 3 years a BSc degree, but the 4-year option is also a BSc degree, but you spend the third year doing some sort of internship in the industry. This is new, actually. So we just welcomed our first cohort like 2 days ago, or something like that. And the data science, you may know that this is a relatively new discipline that combines mathematics, statistics, and the computational approaches to help you deal with data, because the world is now inundated with all sorts of data, and we need people to deal with data on this scale. And it is slightly different from mathematics with statistics because it is more computational. So this degree is designed to give you rigorous training in all these areas, so that this can lead almost immediately to a career in data science, right? So let me go on. And the career option for data science is actually very good. If you just Google for data science jobs, there are hundreds of opening, and lots of companies cannot even find the proper data science people to work for them. And in a way, this is sort of more career-oriented option than a math degree, because if you study math, you can do all sorts of things, but it's not clear what you're going to do. Okay, and you'll find out. But with data science, it is far clearer, because you'll do data science after you finish. But you can also go on to study further. So go on to further PhD studies in data science. And in Bristol, we have a so-called Center for Doctoral Training. So this is a UK type of doctoral training facility so we admit roughly 10 doctoral students per year to this, and this leads to a PhD in data science eventually. And of course, you can, after that degree, you can either still work for a company, or you can be an academic and do research in data science, right? So let me just, why would you want to choose Bristol for data science? I mean, it's similar to sort of mathematics. We're also highly ranked in data science, in statistics specifically. And with data science, we have far more connection with other schools, for example, chemistry, physics, and engineering, and also with the industry, because you have the option to do a third year with an external partner. I'll talk about that at the end. Okay, I'll talk about these so-called unit choices that you have at the end of the presentation. Right. So let me just spend a few minutes talking about physics. So I'm not a physicist myself, but I know a bit about physics. Okay, so the kind of degree we offer in the School of Physics. So this is separate from the School of Mathematics. And on the right side, you see this picture of the School of Physics. It's also a very nice, imposing looking building. Okay. So we have also these BSc or MSci options. So with physics, you also have the option of doing like MSci in physics with industrial experience, where you spend the third year also doing some sort of internship, right? Just like with math, you also have the option to do joint honors. So that means you do half of your studies in physics and half the studies in another field. And so in this case, either mathematics or philosophy, right? With physics, you have the option of also a wide range of optional units from year 2 onwards. So this includes, some of the things you may know about, for example, general relativity, quantum information, all these things just, I think hopefully brings up all sorts of very interesting ideas in your head. And this is obviously a very interesting field as well. So the entry requirement, so I'm going to go on to entry requirements now, right? So it is A*, AA. If you do A levels, so the A* needs to be in math or physics. And if you do IB, it will be 38 points overall. So with 18 at higher levels, obviously you should do some higher level math and physics, right? So if you want to do a physics degree. So now I'm going to go on to speak about entry requirements for math. And you'll see a jumble of information here, but the key thing to remember, so you don't need to read through all these things. So the key thing to remember is the key requirement is A star AA. Sorry, let me just move back. So it's A star AA if you do mathematics and further math. And if you do intend to study mathematics at a university level, we do suggest you do further math at A levels, because otherwise you'll have a lot of catch up to do. Okay, so if you do further math, then we require A star AA. And that translates, well, roughly into 40 points overall, with 18 at high level. And you should obviously, again, do some high level mathematics, or and also some higher level in another mathematics related subjects. And all the joint degrees have a similar type of entry requirements. So it's A star AA, okay? So the IB requirements is either 38 or 40 points. So this kind of information you can find online on our website, right? So I'm not going to dwell on too much on that. Let me just go on to what sort of units you study in the first year and onwards. So in the first year, actually, everybody takes the same units, okay? Because we understand people come from different backgrounds. And so we want to bring everybody up to the same standard so that you can go on to second and third year. And so these are the units on the right side. These are the units. So you have core units, and then you have one specialized unit in one of the three main specialties of mathematics. So these are applied math and pure math and the probability and statistics. So probability and statistics specifically relates to data science, right? And applied math relates to, it relates to more to physics and chemistry. And pure math is like, it's like the foundation of all these things. So these are different things that everybody will learn about. And this is the foundation of a mathematical education. And then, but on the second year, from the second year onwards, you have far more options. So in the second year, a third of the units are fixed. But the rest are optional. So this is when you get to sort of specialize a bit, okay? And from the third and the fourth year, you basically all units are optional, and this is when you choose to specialize in something. For example, you can specialize in statistics, you can specialize in probability or number theory. I mean, the list of options, I'm not going to list everything because there's too many to list. So here are some of the third and the fourth year units, and this is just small, very small sample. So we have more than 30 units in the third and the third year, and more in the fourth year even, okay? So some of the stuff you may not know what they mean. For example, I doubt anybody in high school know what representation theory means, but it doesn't matter. It's a very interesting field, okay? So eventually you go on to, if you spend all the effort, you go on to very interesting things to study in the third and the fourth year, if you build a good foundation in your first and second year. And as you can see, our degree is designed to be pretty flexible. So you design your own degree structure, essentially, right? So you design what you want to specialize in and do what you like, okay? So I think I'm going to skip this because so mainly about assessment. Assessment is mainly by exams, all right? And it's slightly different from the US, where you have like midterms and everything. We mainly focus on a single final exam. That's all we need to do. But you need to obviously do homeworks and etc. But there's a lot of support. There's a lecturer you can have, like, drop into the office to ask questions. We have problem classes, web tutorials, etc., to support your learning, right? So let me just spend the final minute on the data science units. So in data science, the units are slightly different from the math, so the so-called single honors math units, because we just want these data science students to focus more on computing and the statistics. So as you can see, in the first year, you do a scientific computing unit, and you also do some program unit in both R and C. So R, if you don't know, is like the most popular statistical language to learn, and C is the most popular computing language to learn. And so these are slightly different, but yes, but with data science, you have the option to work within, work at an internship at a company. So some of the options are listed here. So for example, you see some of the names you may know. So BAE Systems, they design like fighter jets and the warplanes or whatever. But if you don't want to, oh, sorry, let me go back. But if you don't want to engage in that sort of thing, maybe you want to work for Rolls-Royce. This is not a car company. Okay, this is the that's that's not interesting, but this is a jet engine company. So they employ a lot of mathematicians, physicists, and engineers. So these are all possibilities, right? So I think that's all the time I have, and I'm going to end here and then hand back to Sumi.